The soft chime of the circadian alarm cut through the artificial night. A gentle, blue-hued light, mimicking Earth's sunrise, filled the compact living quarters. The sleep surface integrated into the wall retracted, revealing a small, functional living space. The colonist, Maya, stretched, her muscles tingling from the lower gravity. She tapped her wristwatch, a thin band displaying vital signs and reminders. Today was her shift at the hydroponics lab, a crucial responsibility in their self-sustaining world. A quick glance at the newsfeed showed nothing out of the ordinary. The Mars mission was progressing well, and a new shipment of supplies was due to arrive at the lunar base in 6 months. The rhythmic hum of the life support system was a constant presence. A quick shower in the recycled water system helped her shake off the last vestiges of sleep. A wave of longing for Earth washed over her, but she pushed it down. They were pioneers building a new home for humanity. Breakfast was a simple affair: a protein bar synthesized from algae, a cup of recycled coffee, and a nutrient-dense fruit paste grown in the colony's hydroponics lab. The taste was bland, functional, a far cry from the fresh produce of Earth, but it kept them alive, fueled their bodies for the challenges ahead. Maya joined her fellow colonists in the communal dining area, a brightly lit space with large windows offering a panoramic view of the lunar surface. The sun, a harsh, brilliant disk in the black sky, cast long, sharp shadows across the desolate landscape. Conversations revolved around work assignments, progress reports, and the latest news from Earth. The colonists were a diverse group: scientists, engineers, doctors, and technicians, all united by a common purpose: to build a sustainable human presence beyond Earth. "How are the tomatoes coming along?" asked Ben, a burly engineer responsible for maintaining the colony's power grid. "Still a bit pale," Maya admitted, "but the nutrient solution seems to be working." The hydroponics lab was her domain, a testament to human ingenuity and their struggle for self-sufficiency in the harsh environment of space. Rows upon rows of plants bathed in the glow of LED lights, stretched as far as the eye could see. Lettuce, spinach, tomatoes, even strawberries, all thrived in their carefully controlled environment. Maya slipped into her work suit, a lightweight exoskeleton that provided support in the low gravity and monitored her vital signs. The suit was also equipped with an augmented reality display, overlaying data feeds and instructions onto her field of vision. She ran her hand over the leaves of a tomato plant, checking for signs of stress. Sensors embedded in the soil monitored moisture levels, nutrient content, and temperature, relaying the data back to the central computer. The system was highly automated, but human oversight was still crucial. A blinking red light on her display alerted her to a potential issue in Sector 5. Using her suit's interface, she remotely diagnosed the problem and initiated the repair sequence. Lunch was another no-frills affair: a protein shake synthesized from algae, fortified with vitamins and minerals. It wasn't gourmet, but it was efficient, providing all the necessary nutrients in a single, easily digestible serving. Maya ate in the lab, her eyes glued to the monitoring screens. The plants were her responsibility, and their well-being was paramount to the colony's survival. As she ate, she caught up on the latest news from Earth. A new fusion reactor design had just been successfully tested, promising a future of clean, abundant energy. A bittersweet pang of longing shot through her. She missed Earth, its vibrant chaos, its breathtaking beauty, but she was also proud to be part of something larger than herself, something that held the promise of a future for humanity among the stars. A notification popped up on her display. It was a message from her sister Lena, back on Earth. They had a scheduled video call in 15 minutes. Despite the immense distance, technology allowed them to stay connected. The afternoon was dedicated to exploration, not of the vast lunar landscape just outside their pressurized dome, but of the virtual realms accessible through their neural interfaces. Donning a headset, Maya was transported to a breathtakingly realistic simulation of the Amazon rainforest. She spent hours trekking through the virtual jungle, marveling at the towering trees, the cascading waterfalls, the vibrant life teeming around her. It was a welcome escape from the sterile, controlled environment of the colony. Later, she joined a group of fellow colonists for a virtual reality game, a fast-paced, zero-gravity combat simulation. It was a popular pastime, offering a much-needed adrenaline rush and a chance to test their reflexes in a simulated environment. As the sun began to set in their simulated world, Maya felt a pang of fatigue. Dinner was a communal affair, a time for the colonists to come together and share stories. The menu featured lentil stew made from hydroponically grown vegetables and synthesized protein. It was a vast improvement over the early days of nutrient paste and freeze-dried rations. Conversation flowed easily, punctuated by laughter. After dinner, Maya made her daily video call to her family on Earth. The connection was instantaneous, with minimal lag. Her parents and Lena beamed at her from the screen. It was bittersweet, a reminder of what she left behind, but also a source of comfort. The meal ended with a dessert of sorts, a sweet, tangy fruit salad made from hydroponically grown berries. It was a testament to their progress, a reminder that even in this harsh, unforgiving environment, they could create something that resembled the simple pleasures of life on Earth. As they ate, Maya couldn't help but marvel at the ingenuity and resilience of the human spirit. They were living proof that humanity could adapt, overcome, and thrive, even in the most challenging of circumstances. The conversation drifted towards the future, to the possibility of one day terraforming the moon, transforming it into a second Earth. "Imagine," said Ben, his eyes gleaming with a dreamer's spark, walking on the lunar surface without a spacesuit, breathing fresh air, feeling the warmth of the sun on your skin. It seemed like an impossible dream, yet somehow within the realm of possibility. They were, after all, already growing food, recycling water, creating a self-sustaining ecosystem within their dome. Evenings were a time for relaxation and socializing. Some colonists gathered in the recreation area, a spacious dome with a simulated sky that cycled through various Earth-like weather patterns. They played games, watched movies, or simply chatted, enjoying each other's company. Others, like Maya, preferred to explore the vast digital libraries accessible through their neural interfaces, immersing themselves in books, music, and art from Earth. Tonight, Maya was attending a virtual concert, a live performance streamed directly from Earth. The music, a blend of classical and electronic, washed over her, transporting her to another place and time. It was a reminder of the beauty and creativity that still flourished on their home planet. As the concert ended, Maya logged off, a sense of peace settling over her. Despite the challenges of their existence, the isolation, the constant awareness of their fragility, there was beauty to be found in their lives. They had purpose, camaraderie, and the unwavering belief that they were building a better future for humanity. Life in the colony wasn't always easy. Isolation, confinement, and constant danger took a toll on their mental well-being. The silence of space, broken only by the hum of life support systems, could be deafening. They missed fresh air, the feel of wind, and the scent of rain-soaked earth. Maya missed her family, the warmth of their embrace, their laughter. She missed walking barefoot on grass, feeling the sun, breathing fresh air. The weight of their mission often felt crushing. Counselors helped them cope with the psychological challenges. Maya had regular sessions, talking through her anxieties and hopes. It helped, knowing she wasn't alone. They were pioneers, pushing human endurance and adaptability. As the artificial night descended upon the dome, casting long shadows across the living quarters, Maya prepared for sleep. The blue-hued light, mimicking Earth's twilight, gradually dimmed, signaling the end of another day. The rhythmic hum of the life support system, a constant lullaby, filled the air. She slipped into the sleep surface, its contours molding to her body, providing a sense of comfort and security. She closed her eyes, and for a moment she could almost imagine the scent of her mother's lavender soap, the sound of her father's gentle snores, the warmth of Lena's hand in hers. Then, the memories faded, replaced by the stark beauty of the lunar landscape, the endless expanse of stars stretching out before her, a canvas of infinite possibilities. They were explorers, pioneers, guardians of humanity's future. She closed her eyes, surrendering to the embrace of sleep, dreaming of Earth, of stars, of the future they were building together. In the quiet hours before the simulated dawn, Maya dreamed. She dreamed of Earth, of lush green fields and sparkling blue oceans. She dreamed of her family, their faces etched with love and concern. But she also dreamed of the moon, of their colony, of the future they were building together. She saw children running through hydroponic gardens filled with colorful flowers and plump fruits. She saw families picnicking beneath a shimmering artificial sky, their laughter echoing through the dome. She saw humanity, not just surviving, but thriving, in this new, challenging environment. And as the first rays of the artificial dawn pierced through the darkness, she woke with a renewed sense of purpose. They were pioneers, forging a new path for humanity among the stars. The challenges were immense, the risks undeniable, but so were the rewards. Humanity has always looked to the stars. We long to explore the cosmos. We dream of finding new worlds. By 2125, this dream may become a reality. We may begin terraforming. This is the process of transforming a barren planet into a habitable world. It is a monumental task, but the rewards are immeasurable. A new Earth awaits us. Terraforming is a complex process. It involves altering a planet's environment. We must make it suitable for life as we know it. This means creating a breathable atmosphere. We need liquid water on the surface, and we must establish a stable temperature range. It is a delicate balancing act. Each element influences the others. Terraforming requires advanced technology. We need powerful tools to alter a planet's environment. Giant orbital mirrors could reflect sunlight onto the surface. This would warm the planet. Massive factories could release greenhouse gases. This would thicken the atmosphere. Genetically engineered organisms could convert the Martian soil. This would make it suitable for plant life. Mars is the most promising candidate for terraforming. It is relatively close to Earth. Mars has some similarities to our planet. It has polar ice caps. It has a 24-hour day-night cycle. And there is evidence of past liquid water on its surface. These factors make Mars the ideal candidate for transformation. Section 5. The Martian Challenge, Transforming a Hostile World. Terraforming Mars will be a formidable challenge. The planet is currently a cold, dry desert. Its atmosphere is thin and unbreathable. The surface is bombarded by harmful radiation. Overcoming these obstacles will require ingenuity and perseverance, but the potential rewards are too great to ignore. Section 6. Engineering an Atmosphere. From thin air to breathable skies. Creating a breathable atmosphere on Mars is a top priority. This ambitious goal is essential for the long-term survival of human colonies on the Red Planet. Without a breathable atmosphere, humans would be confined to sealed habitats, relying on life support systems indefinitely. The challenge is immense, but so are the rewards. One method involves releasing greenhouse gases. These gases, such as carbon dioxide and methane, are known for their ability to trap heat. By introducing them into the Martian atmosphere, scientists aim to create a greenhouse effect similar to that on Earth. These gases trap heat and warm the planet. The increase in temperature is crucial for several reasons. Not only does it make the surface more hospitable, but it also initiates a series of chemical and physical reactions that further enhance the atmosphere. As the temperature rises, frozen carbon dioxide in the polar ice caps would sublimate. This process releases additional CO2 into the atmosphere, creating a positive feedback loop. The more CO2 released, the warmer the planet becomes and the more ice sublimates. This would thicken the atmosphere. A thicker atmosphere means better protection from harmful solar radiation and a more stable climate. Over time, this could lead to the formation of clouds and even precipitation, further transforming the Martian environment. Eventually, it could reach a pressure suitable for humans. This would be a monumental achievement, allowing humans to walk on the Martian surface with minimal protective gear. The dream of turning Mars into a second home for humanity would move one step closer to reality. The journey is long and fraught with challenges, but the vision of breathable skies on Mars continues to inspire scientists and dreamers alike. Section 7. Water, the elixir of life on the Red Planet. Water is the cornerstone of life as we know it. Without it, life on Earth would not exist, and the same holds true for any potential life on Mars. Water is essential for life. It is the medium in which all known biological processes occur. From the simplest single-celled organisms to the most complex multicellular life forms, water is a fundamental requirement. Fortunately, Mars possesses large amounts of water ice. This ice is not just a potential resource, it is a treasure trove that could unlock the secrets of the Red Planet's past and pave the way for its future. This ice is locked away in the polar caps and beneath the surface. The challenge lies in accessing and utilizing this frozen reservoir. Scientists and engineers are developing innovative methods to extract and use this ice. By warming the planet, we could melt this ice. Advanced technologies such as orbital mirrors and greenhouse gas factories could be employed to raise the temperature of Mars, initiating a process of controlled melting. This would create oceans, lakes, and rivers. These bodies of water would not only provide a habitat for potential Martian life, but also serve as a critical resource for human explorers and settlers. Liquid water is crucial for both human survival and the development of a Martian biosphere. It would enable agriculture, support human consumption, and be used in various industrial processes. The presence of liquid water would transform Mars from a barren wasteland into a thriving, habitable world. Imagine a future where humans walk along the shores of Martian lakes, where green plants grow under the Martian sun, and where the red planet becomes a second home for humanity. This vision is not just a dream, it is a possibility that we are actively working towards. The elixir of life on Mars is within our reach, and with it, the potential for a new chapter in the story of human exploration and survival. Section 8. Temperature Control. Warming Mars to a temperate climate. Mars is currently extremely cold. Its average surface temperature is minus 63 degrees Celsius. To make it habitable, we need to raise the temperature significantly. Giant orbital mirrors could reflect sunlight onto the planet's surface. This would warm the atmosphere and melt the ice caps. Section 9. Seeds of Life. Establishing a Martian biosphere. Once we have a breathable atmosphere and liquid water, we can begin introducing life. Genetically engineered microorganisms could play a vital role. These organisms could convert the Martian soil. They would make it suitable for plant growth. Over time, a diverse biosphere could develop. This would create a self-sustaining ecosystem on Mars. Section 10. The Promise of a New Home. Benefits of terraforming. Terraforming Mars offers numerous benefits to humanity. It would provide us with a second home. This would safeguard our species against extinction. It would open up vast new resources and opportunities, and it would inspire future generations to explore the cosmos. Section 11. Ethical Considerations. Terraforming and Planetary Stewardship. Terraforming raises ethical questions. Do we have the right to alter other planets? What if there is microbial life on Mars? Should we preserve it? These are complex issues. We must proceed with caution and responsibility. We must ensure that our actions are ethical and sustainable. Section 12. A Future Among the Stars. Terraforming and Humanity's Destiny. As we stand on the brink of a new era, the concept of terraforming has captured the imagination of scientists, engineers, and dreamers alike. The idea of transforming a barren, inhospitable planet into a thriving, Earth-like environment is no longer confined to the realm of science fiction. It is becoming a tangible goal, a beacon of hope for humanity's future. Terraforming is a testament to human ingenuity. It represents our ability to harness advanced technology and scientific knowledge to reshape entire worlds. The process involves altering the atmosphere, temperature, surface topography, and ecology of a planet to make it habitable for human life. This monumental task requires the collaboration of experts from various fields, including climatology, geology, biology, and engineering. It is a symbol of our ambition to reach for the stars. Our desire to explore and colonize new worlds is driven by the innate human spirit of curiosity and adventure. The challenges we face in this endeavor are immense, but so are the rewards. Successfully terraforming a planet would not only ensure the survival of our species, but also open up limitless possibilities for future generations. By 2125, we may be on the cusp of creating a new Earth. Imagine a world where humans can walk on the surface of Mars without the need for spacesuits, where lush green forests and flowing rivers replace the barren red landscape. This vision is within our reach, thanks to the relentless efforts of scientists and engineers who are pushing the boundaries of what is possible. This would be a defining moment in human history. The successful terraforming of another planet would be a testament to our resilience, creativity, and determination. It would be a milestone that future generations would look back on with pride, knowing that they are part of a species capable of achieving the extraordinary. This achievement would inspire countless individuals to pursue careers in science, technology, engineering, and mathematics, driving further innovation and progress. It would mark the beginning of our journey to become a multi-planetary species. The establishment of human colonies on other planets would not only ensure our survival in the face of potential global catastrophes, but also foster a sense of unity and shared purpose among all of humanity. As we look to the stars, we are reminded that our destiny is not confined to Earth. The universe is vast, and our potential is limitless. The journey of terraforming and colonizing new worlds is just the beginning of an exciting new chapter in the story of humanity. The Moon, a celestial neighbor, a constant companion in the vast expanse of space, a beacon in the night sky, its silvery glow has guided travelers and inspired poets. For millennia, it has captivated humanity, inspired awe and wonder. From ancient civilizations to modern times, the moon has been a source of mystery and fascination. Our ancestors told stories about it. Myths and legends were born under its light, drew pictures on cave walls. Early humans recorded their lunar observations in art and artifacts. The moon, a silent observer to human history. Telescopes brought us closer, revealed craters and mountains. The invention of the telescope in the 17th century marked a turning point in our understanding of the moon. The space race ignited a new era. Nations competed to reach the moon, pushing the boundaries of technology and human endurance. Dreams of walking on the moon became reality. Astronauts trained rigorously, preparing for the ultimate journey. In 1969, Neil Armstrong took one small step. His words echoed around the world, a giant leap for mankind. But we didn't stay. The Apollo missions ended, and the moon remained a distant dream. After Apollo, the moon remained out of reach. The focus shifted to other space endeavors, leaving the lunar surface untouched for decades. Now, a new generation dares to dream. With advancements in technology, the moon is once again within our grasp. To return to the moon, space agencies around the world are planning new missions, aiming to explore and utilize lunar resources, not just to visit, to stay. The vision of establishing a permanent human presence on the moon is becoming a reality. The next chapter of lunar exploration is about to begin. The year 2040 marks a turning point. A permanent human presence on the moon, a lunar base, a home away from home. Ambitious? Yes. Impossible? No, this is not science fiction, it's a global endeavor. Nations and private companies working together, a shared vision of exploration and discovery, the moon as a stepping stone to unlock the secrets of the universe. Why the moon? It's close, resources are abundant, water ice in permanently shadowed craters, a potential source of fuel and life support, the moon, a stepping stone to Mars and beyond. Building a lunar base requires ingenuity, new technologies, solutions to complex problems. We need advanced life support systems. To create breathable air and grow food, radiation shielding is crucial, protecting astronauts from harmful cosmic rays. Transportation is key. Reusable spacecraft, landers that can deliver cargo and crew. Robotics will play a vital role. Autonomous rovers, construction robots, easing the burden on human explorers. 3D printing offers exciting possibilities, using lunar regolith to build structures, reducing dependence on Earth-based materials. The challenges are great, but the rewards are greater. Imagine living on the moon, a day that lasts 28 Earth days, no atmosphere to speak of, extreme temperatures, harsh conditions for even the hardiest life forms. Our lunar base must protect us from the vacuum of space, from radiation, from the constant bombardment of micrometeoroids. Habitats must be strong yet lightweight, easy to transport and assemble. We must utilize lunar resources, water ice for drinking, oxygen, rocket fuel, regolith for construction. The goal: self-sufficiency, minimizing reliance on Earth, creating a sustainable presence on the moon. Section 5. The perils of space radiation, micrometeoroids, and lunar dust. Space is not a forgiving environment. Astronauts face constant threats: radiation from the sun and deep space, micrometeoroids traveling at incredible speeds, and then there's the dust. Lunar dust is unlike anything on Earth. Fine, abrasive, and electrostatically charged, it gets everywhere, clogs equipment, poses a health hazard to astronauts. Mitigating these risks is paramount. Radiation shielding is essential, both for habitats and spacesuits. Early warning systems for solar flares, specialized airlocks to prevent dust from entering living areas. Safety is paramount. Section 6. Powering the moon base, energy solutions for a harsh environment. A lunar base needs power, lots of it, to run life support systems, power equipment and experiments. But the moon's long nights pose a challenge. Solar panels alone won't suffice. Nuclear power offers a viable solution. Small modular reactors providing a constant and reliable source of energy. Other options are being explored: fuel cells, regenerative energy systems. Energy storage is crucial. Advanced batteries, thermal energy storage, ensuring power availability during lunar nights. A robust and reliable power grid, essential for a permanent human presence. Section 7, a global endeavor, international collaboration for lunar exploration. The moon belongs to no one, and to everyone. International collaboration is key, sharing the costs, pooling resources and expertise, learning from each other. Space agencies around the world are working together: NASA, ESA, Roscosmos, JAXA, CNSA, a global effort to return to the moon and build a lasting legacy. This is not a competition, it's a partnership, a shared vision of exploration, expanding our knowledge, pushing the boundaries of human ingenuity. Together, we can achieve great things. Section 8. The rise of private spaceflight, new players in the lunar game. Private companies are joining the race: SpaceX, Blue Origin, Rocket Lab, developing new technologies, lowering the cost of access to space. These companies bring innovation and entrepreneurial spirit. They see the moon as an opportunity for research, for resource extraction, for tourism. The possibilities are endless. This new era of space exploration is exciting. It's creating jobs, boosting the economy, inspiring future generations. The private sector is a vital partner in our quest to conquer the final frontier. Section 9. Scientific discoveries await, unlocking the moon's secrets. The moon, our closest celestial neighbor, has always been a source of wonder and mystery. For centuries, humans have gazed up at its silvery glow, pondering its secrets and its role in the cosmos. The moon holds many mysteries. Its surface, marked by craters and shadows, tells a story of a turbulent past. Each crater is a chapter in the moon's history, revealing the impacts that have shaped it over billions of years, clues to the early solar system, the formation of planets. By studying the moon, we can unlock secrets about the early solar system, providing insights into how planets, including Earth, were formed. The history of our own planet. The moon acts as a time capsule, preserving the history of our solar system and offering a unique perspective on the evolution of our own planet. A laboratory for scientific discovery. The moon serves as an unparalleled laboratory for scientific research, where experiments can be conducted in an environment free from Earth's atmospheric interference. Lunar telescopes can peer deep into the universe, unobstructed by Earth's atmosphere. These telescopes can capture clearer images of distant stars, galaxies, and other celestial phenomena, providing data that is impossible to obtain from Earth. We can study the cosmos in unprecedented detail. From the moon, we can observe the universe with a clarity that surpasses any Earth-based observatory, allowing us to make groundbreaking discoveries, unlocking the secrets of black holes, galaxies, and the origins of the universe. The moon's vantage point enables us to delve deeper into the mysteries of black holes, the formation of galaxies, and the very origins of the universe itself. The moon's geology is fascinating. Its surface is a treasure trove of geological features, from ancient lava plains to towering mountain ranges, each telling a story of the moon's dynamic history. Impact craters tell a story of cosmic collisions. These craters are not just scars on the lunar surface, they are records of the cosmic events that have shaped the moon, and, by extension, our solar system. Volcanic features hint at a once active interior. The presence of volcanic features suggests that the moon once had a molten interior, providing clues about its thermal evolution and geological activity. By studying the moon, we learn more about Earth and our place in the cosmos. The moon is not just a distant rock in the sky, it is a key to understanding our own planet's past, present, and future, and our place in the vast universe. Section 10. A stepping stone to Mars and beyond. The moon as a launch pad. The moon is not our final destination, it's a stepping stone, a crucial waypoint in our journey to explore the cosmos. It serves as a proving ground for technologies, for long-duration spaceflight, and for the systems that will sustain human life far from Earth. Here, we can test the limits of our ingenuity, for living and working on another celestial body, in an environment that is both challenging and rewarding. The lessons learned on the moon will pave the way. They will inform the design of habitats, life support systems, and the protocols for future missions. These lessons are crucial for our future missions to Mars, to the asteroid belt and beyond, to the distant moons of Jupiter and Saturn. Each step we take on the moon brings us closer to these distant worlds. The moon is a launch pad, a springboard for humanity's next giant leap into the unknown. For humanity's next giant leap. A leap that will take us to new frontiers and new possibilities. Establishing a permanent presence on the moon. Building the infrastructure that will support future generations of explorers. It's not just about science, it's about survival. About creating a sustainable way of life beyond Earth. About ensuring the long-term future of our species. By learning to live and thrive in space, by becoming a multi-planetary species, we open up new horizons and new opportunities for all of humanity. Section 11. A new era of exploration inspiring future generations. The quest to explore is in our DNA. It's what makes us human. Curiosity, the desire to push boundaries, to seek new knowledge, to boldly go where no one has gone before. Building a base on the moon. It's not just about bricks and mortar, it's about inspiration, about igniting the imagination of future generations, about showing them what's possible. Imagine a future where children dream of becoming lunar geologists, spacecraft engineers, astrophysicists. A future where humanity reaches for the stars. The moon is just the beginning. The future of exploration is. For millennia, humanity has gazed upon the celestial tapestry, our eyes drawn to a crimson beacon in the night sky, Mars. Named after the Roman god of war, this enigmatic planet has captivated our imaginations and sparked countless tales of otherworldly encounters. Today, that red dot in the heavens beckons us with the allure of a new frontier, a new home for humankind amidst the stars. The dream of living on Mars is rapidly becoming a tangible goal, a testament to our spirit of innovation. By 2070, this vision could be a reality, with the first self-sustaining city on the Martian surface. This ambitious endeavor will require overcoming formidable challenges and adapting to a planet vastly different from our own. Establishing a permanent human presence on Mars would expand our knowledge and serve as an insurance policy for our species. The journey to Mars will be long and arduous, demanding unwavering commitment and global cooperation. But the allure of exploring a new world and securing a future for humanity among the stars is a siren call we cannot ignore. Let us embark on this extraordinary adventure together and write the next chapter of human history on the dusty plains of Mars. The first hurdle in our Martian odyssey is developing reliable, cost-effective transportation. Current chemical rockets are limited by fuel efficiency and journey duration, taking 6 to 8 months. Scientists are exploring nuclear thermal rockets and ion propulsion to shorten travel times. These technologies could reduce the journey to weeks, minimizing astronaut exposure to deep space hazards. Reusable spacecraft for multiple interplanetary voyages are crucial for sustainable Mars missions. Imagine a future where journeying to Mars is as routine as transatlantic flights. Constructing a city on Mars presents a unique set of challenges not encountered on Earth. The thin Martian atmosphere, lack of a global magnetic field, and extreme temperature fluctuations necessitate innovative approaches to habitat design and construction. One promising solution lies in the use of three-dimensional printing technology to create habitats from Martian regolith, the loose, unconsolidated material that covers the planet's surface. Regolith, when mixed with a binding agent, can be used to create durable and insulated structures that offer protection from the harsh Martian environment. These Martian dwellings would need to be entirely self-sufficient, equipped with advanced life support systems to regulate atmospheric pressure, temperature, and air composition. Solar and nuclear power would provide a reliable energy source, while closed-loop recycling systems would be essential for managing waste and conserving precious resources like water and oxygen. To shield inhabitants from harmful radiation, habitats could be built underground or within existing Martian lava tubes, natural caverns formed by ancient volcanic activity. These subterranean dwellings would provide natural shielding from cosmic rays and solar flares, creating a safer and more habitable environment for Martian settlers. One of the most significant threats to human health on Mars is the high level of radiation that bombards the planet's surface. Unlike Earth, Mars lacks a global magnetic field and a thick atmosphere, leaving it vulnerable to cosmic rays and solar flares. Long-term exposure to this radiation can damage DNA, increasing the risk of cancer and other health problems. Protecting Martian inhabitants from this invisible threat is crucial for the long-term viability of human settlements. To mitigate this danger, Martian habitats will need to incorporate radiation shielding into their design. Constructing habitats underground or within Martian lava tubes offers natural protection. Utilizing Martian regolith in construction provides an effective barrier against radiation. Advancements in material science could lead to lightweight, radiation-resistant materials for spacesuits and habitats. These materials would provide an additional layer of protection for Martian explorers and settlers alike. Researchers are exploring dietary supplements and pharmaceuticals to mitigate radiation effects. These advancements would further enhance the safety and well-being of humans living on Mars. Section 5. From barren soil to bountiful harvest. Establishing a self-sustaining presence on Mars requires developing reliable food sources independent of Earth's resources. Fortunately, while the Martian soil lacks the essential nutrients found in Earth's soil, it can be enriched and cultivated to support plant growth. Hydroponic farming, a method of growing plants without soil using nutrient-rich water solutions, offers a promising solution for Martian agriculture. This technique allows for precise control over growing conditions and maximizes water efficiency, crucial in the arid Martian environment. Another promising approach is the use of aeroponics, where plants are grown suspended in air and periodically sprayed with a nutrient solution. This method requires even less water than hydroponics and allows for vertical farming, maximizing crop yield within a limited space. Scientists are also exploring the possibility of genetically modifying crops to thrive in Martian conditions. By enhancing their tolerance to drought, radiation, and low atmospheric pressure, we can create crops specifically adapted to the challenges of Martian agriculture. Section 6. Water, the elixir of Martian life. Water is essential for human survival and is a critical resource for various applications, from agriculture to industrial processes. While Mars harbors water ice in its polar regions and beneath its surface, accessing and utilizing this resource is crucial for sustaining human settlements. One proposed method involves harvesting water ice from Martian glaciers or extracting it from hydrated minerals found in the Martian soil. This water can then be purified and used for drinking, agriculture, and other purposes. Another approach involves developing technologies that can extract moisture directly from the Martian atmosphere. Although thin, the Martian atmosphere contains trace amounts of water vapor that can be condensed and collected using specialized devices. Furthermore, efficient water recycling systems will be paramount in Martian settlements. By treating and reusing wastewater from various sources, we can significantly reduce the demand for fresh water and create a more sustainable closed-loop system. Section 7. A day in the life of a Martian pioneer. Imagine waking up in your cozy Martian habitat, the soft glow of artificial sunlight filtering through the windows. After a breakfast of fresh vegetables harvested from the hydroponic garden, you don your spacesuit and venture out into the Martian morning. Your first task is to inspect the solar panels that provide power to your habitat, ensuring they are free of dust and functioning optimally. Afterward, you head to the greenhouse, where you assist in the cultivation of crops, monitoring their growth and adjusting nutrient levels as needed. Later in the day, you join a team of geologists on an expedition to a nearby canyon, where you collect rock samples and analyze the geological formations, searching for clues about Mars's past and the potential for past life. As the sun begins its descent, casting long shadows across the Martian landscape, you return to your habitat, exhausted but exhilarated from a day of exploration and discovery. In the evening, you connect with loved ones back on Earth, sharing stories and experiences from your extraordinary life on Mars. Section 8. The Red Planet Blues Challenges to Human Well-Being. Living on Mars is exciting, but it comes with psychological and physiological challenges. Isolation and confined spaces could affect mental health. Prioritizing mental health and community is essential. Lower gravity may cause muscle and bone loss. Rigorous exercise and artificial gravity can help. The Martian diet might lack variety, affecting nutrition and morale. A multidisciplinary approach is needed to ensure well-being. Section 9. Forging a New Society, Martian Governance and Culture. As the Martian population grows, establishing a system of governance and fostering a unique Martian culture will be essential for creating a thriving and harmonious society. The challenges of living on Mars will likely necessitate a collaborative and community-driven approach to governance, with decisions made collectively for the benefit of all inhabitants. The harsh environment and limited resources may foster a culture of resourcefulness, innovation, and mutual support. Martian culture will likely be shaped by the unique challenges and opportunities of living on a new planet. New traditions, holidays, and art forms may emerge, reflecting the spirit of exploration, discovery, and resilience that defines the Martian experience. The relationship between Mars and Earth will also be a defining factor in Martian governance and culture. Whether Mars remains closely tied to Earth or eventually seeks independence, the bond between the two planets will undoubtedly shape the course of Martian history. Section 10. A giant leap for humanity. The significance of Mars colonization. Establishing a permanent human presence on Mars represents a pivotal moment in human history, akin to our ancestors' migration out of Africa, or the first steps on the Moon. The knowledge gained from studying Mars, its geology, atmosphere, and potential for past or present life, could revolutionize our understanding of our place in the universe. Furthermore, the technological advancements required to overcome the challenges of Martian colonization will undoubtedly lead to spin-off technologies benefiting humanity here on Earth. Perhaps most importantly, establishing a self-sustaining human presence on another planet serves as an insurance policy for our species. By diversifying our habitats and expanding beyond Earth, we safeguard humanity against potential existential threats, ensuring the survival of our species for generations to come. Section 11. Mars and Beyond, a Future Among the Stars. The colonization of Mars is not the end goal, but rather a stepping stone on humanity's journey into the cosmos. As we gain experience and expertise in interplanetary living, we pave the way for even more ambitious missions to the outer solar system and beyond. The moons of Jupiter and Saturn, with their subsurface oceans and potential for harboring life, beckon as tantalizing targets for future exploration. And as our technology continues to advance, perhaps one day, we will even venture beyond our solar system, seeking out new worlds and new civilizations among the stars. The future of humanity lies not solely on Earth but among the stars. By embracing the challenges and opportunities of space exploration, we embark on a journey of discovery, innovation, and boundless potential, securing a future for our species that is as vast and awe-inspiring as the cosmos. The universe beckons. For centuries we have gazed at the stars and wondered, are we alone? This question has haunted humanity since the dawn of our existence. The night sky, with its countless twinkling lights, has always been a source of mystery and inspiration. Are there other worlds out there waiting to be discovered? With the advent of modern astronomy, we have begun to uncover the secrets of these distant realms. Exoplanets orbiting stars far beyond our own solar system have become a focal point of scientific inquiry. The idea of interstellar travel, once confined to the realm of science fiction, is steadily moving into the realm of possibility. Advances in technology and our understanding of the universe are bringing us closer to making this dream a reality. By the year 2250, building an interstellar ark, a self-sustaining spaceship capable of carrying humans to other star systems, might become our greatest endeavor. This monumental task will require the combined efforts of scientists, engineers, and visionaries from around the globe. Imagine a vessel, a miniature Earth, gliding silently through the vast cosmic ocean. This ark would be a marvel of human engineering, designed to sustain life for generations as it journeys through the stars. It carries within it the hopes and dreams of humanity, a future generation ready to inherit a new world. These pioneers would be the torchbearers of our species, venturing into the unknown to secure a future for all of us. This is the dream of the interstellar ark, a testament to human ingenuity and our unyielding desire to explore the cosmos. The ship would be equipped with advanced ecosystems, capable of supporting a diverse range of life forms. The concept of interstellar arks has captivated our imagination for decades. From the pages of science fiction novels to the silver screen, these colossal ships have been a symbol of hope and adventure. Science fiction writers from Jules Verne to Arthur C. Clarke have envisioned colossal ships carrying humans across the stars. Their stories have painted vivid pictures of what our future might hold, inspiring generations to dream big. These stories, though fictional, often serve as inspiration, pushing the boundaries of what we believe is possible. They challenge us to think beyond our current limitations and to imagine a future where interstellar travel is within our grasp. As we stand on the cusp of this new era of exploration, the dream of building an interstellar ark is no longer a distant fantasy. With each passing day, we move closer to turning this dream into a reality. It's a challenge that we might be ready to accept, a testament to our relentless pursuit of knowledge and our innate desire to reach for the stars. The journey will be long and arduous, but the rewards could be beyond our wildest dreams. Imagine the day when humanity sets foot on a new world, a planet orbiting a distant star. This moment would mark the beginning of a new chapter in our history, a testament to our resilience and our unyielding spirit of exploration. The dream of distant stars is not just about reaching new worlds, it's about inspiring future generations to look up at the night sky and wonder. It's about igniting the spark of curiosity and the desire to explore the unknown. This dream will require global collaboration, bringing together the brightest minds from every corner of the Earth. Together, we can overcome the challenges and make interstellar travel a reality. As we embark on this journey, we carry with us the hopes and dreams of all humanity. The stars are within our reach, and the universe awaits our arrival. The journey to another star system is fraught with challenges. It's a monumental task that requires overcoming numerous obstacles, both known and unknown. The distances are immense. Measured in light years, the distance light travels in a year. To put it into perspective, light travels at about 186,282 miles per second, and in 1 year, it covers nearly 6 trillion miles. Even the closest star system, Alpha Centauri, is 4.37 light-years away. This means that even at the speed of light, it would take over 4 years to reach it. Traditional chemical rockets, like those that took us to the moon, are insufficient for such a journey. They were designed for short trips within our solar system, not for interstellar travel. They lack the speed and fuel efficiency needed to traverse these vast cosmic distances. The fuel required for such a journey would be prohibitively massive, making it impractical. We need revolutionary propulsion systems, technologies that can propel our ark at a significant fraction of the speed of light. Concepts like nuclear fusion, antimatter engines, and even warp drives are being explored. Another challenge is time. Even if we could travel at near light speeds, the journey would still take decades, if not centuries, from the perspective of those on Earth. This means that the mission would span multiple generations. This means the ark must be self-sufficient, capable of sustaining a closed-loop ecosystem and multiple generations born and raised in the void of space. It would need to recycle air, water, and nutrients efficiently. The psychological impact of such a journey on the crew is another factor to consider. Living in isolation, far from Earth, can take a toll on mental health. Confined within the ark for generations, the crew will face unique psychological and social challenges. They will need to maintain a sense of purpose and community to avoid feelings of isolation and despair. Designing a living environment that caters to their mental and emotional well-being will be crucial to the mission's success. This includes providing recreational activities, social interaction opportunities, and mental health support systems. The interstellar challenge is not just a test of technology, but also of human resilience and ingenuity. Building an interstellar ark demands materials with exceptional properties. The ark needs to withstand the harsh conditions of space, from extreme temperatures and radiation to micrometeoroid impacts. Nanotechnology could hold the key to creating these supermaterials. Imagine materials that are incredibly strong, yet lightweight, capable of self-repair, and adapting to different environments. These advancements would be crucial in constructing a vessel capable of withstanding the rigors of interstellar travel. The ark's design must be both functional and self-sustaining. It needs to house a large crew and provide ample space for agriculture, water recycling, and energy generation. Imagine vast hydroponic farms bathed in artificial sunlight, producing food for the crew. Picture advanced recycling systems that purify water and air, ensuring a closed-loop life support system. The ark's design will be a marvel of engineering, a testament to our ability to recreate Earth's delicate balance in the harsh environment of space. It will be a testament to our ingenuity and our determination to create a future among the stars. Section 4. Fueling the journey propulsion systems. Traditional chemical rockets are inadequate for interstellar travel. Their fuel limitations and relatively low speeds make them impractical for journeys spanning light years. To reach the stars, we need to explore new frontiers in propulsion technology. One promising concept is nuclear fusion propulsion. By harnessing the power of nuclear fusion, the same process that powers the stars, we could achieve significantly higher speeds, potentially a fraction of the speed of light. Imagine a spacecraft propelled by the energy of a miniature sun, hurtling through the cosmos at incredible speeds. Another concept is the antimatter engine. Antimatter, when it comes into contact with matter, annihilates in a burst of pure energy. This energy release is far more efficient than any chemical reaction, making antimatter a theoretically ideal fuel source for interstellar travel. However, producing and storing antimatter remains a significant challenge. Developing these advanced propulsion systems will be a monumental undertaking, requiring breakthroughs in physics and engineering. But the potential rewards, the ability to traverse the vast distances between stars, make it a challenge worth pursuing. Section 5. A world within a world: life support and ecosystems. An interstellar ark is more than just a spaceship, it's a self-contained world, a microcosm of Earth traveling through the vastness of space. It needs to provide everything its crew needs to survive for generations, ensuring that every essential aspect of life is meticulously managed and maintained. This includes a breathable atmosphere, clean water, and a constant supply of food. These are the fundamental pillars of life support that must be flawlessly integrated. Advanced life support systems will be crucial, incorporating cutting-edge technology to monitor and regulate the environment within the ark. These systems will mimic Earth's natural cycles, recycling air and water, processing waste, and maintaining a stable climate within the ark. The goal is to create a seamless, self-sustaining loop. Imagine a closed-loop ecosystem where plants purify the air, water is recycled and reused, and waste is converted into resources. This intricate balance is essential for long-term survival. The ark will need to be a biosphere, a self-sustaining ecosystem capable of supporting a diverse range of life forms. This includes not just humans, but also plants and animals that contribute to the ecological balance. This biodiversity will be crucial for the long-term stability and resilience of the ark's ecosystem. Each species plays a role in maintaining the health and functionality of the environment. Imagine walking through lush gardens within the ark, surrounded by a diverse array of plants and animals, a testament to the resilience of life. These gardens will not only provide sustenance but also a sense of normalcy and connection to Earth. Creating a self-sustaining ecosystem within the confines of a spaceship is a daunting task. It requires the collaboration of experts from various fields working together to solve complex problems. It requires a deep understanding of ecology, biology, and engineering. Each discipline brings unique insights and solutions to the table, ensuring that the ecosystem can thrive in the harsh environment of space. But it is a challenge we must overcome if we are to succeed in our quest to reach the stars. The journey will be long and arduous, but the rewards of creating a new home among the stars are immeasurable. As we look to the future, the vision of a thriving, self-sustaining ecosystem in space becomes a symbol of hope and human ingenuity. It represents our ability to adapt, innovate, and persevere in the face of the unknown. Together we can build a world within a world, ensuring that life not only survives but flourishes as we embark on this incredible journey into the cosmos. Europa, a moon of Jupiter, shines brightly in our solar system. This icy world orbiting the gas giant has captivated the imaginations of scientists and dreamers alike. Its surface, a frozen expanse of ice, reflects the sunlight, making it one of the brightest objects in the night sky. Covered in ice, this celestial body holds a secret, a vast ocean of water beneath its surface. This ocean, hidden from view, is kept warm by the gravitational forces exerted by Jupiter, creating a dynamic environment beneath the icy crust. The ice itself is constantly shifting and cracking, hinting at the turbulent waters below. Europa is a beacon of hope, a potential cradle for life beyond Earth. Scientists believe that where there is water, there could be life. The possibility of finding even the simplest forms of life in Europa's ocean has driven countless studies and missions. The discovery of life on Europa would revolutionize our understanding of biology and the potential for life elsewhere in the universe. As we gaze at the stars, we dream of reaching out, of exploring the vast unknown. The allure of Europa is not just in its potential for life, but in the challenge it presents. It calls to the explorer in all of us, urging humanity to push the boundaries of what is possible. Europa beckons, promising answers to some of humanity's oldest questions. What lies beneath its icy surface? Could we one day send a mission to drill through the ice and explore the ocean below? These questions drive the scientific community to develop new technologies and strategies for exploration. Could life exist beyond our planet? Europa's potential is undeniable. The conditions beneath its ice are thought to be similar to those in Earth's deep oceans, where life thrives around hydrothermal vents. If similar conditions exist on Europa, it raises the tantalizing possibility that life could have independently arisen there. Its subsurface ocean is thought to contain more water than all of Earth's oceans combined. This vast reservoir of water, shielded from the harsh environment of space, could be teeming with microbial life. The sheer volume of water increases the chances that life could exist in some form. This hidden ocean, shielded from the harsh radiation of space, might offer the perfect conditions for life to evolve. The ice acts as a protective barrier, maintaining a stable environment where life could potentially thrive. The presence of salts and minerals in the water further supports the idea that Europa could harbor life. The possibility, however remote, is too tantalizing to ignore. The search for life on Europa is not just about finding extraterrestrial organisms, it's about understanding our place in the universe. Are we alone, or is life a common occurrence in the cosmos? Europa holds the key to answering these profound questions. Europa is a challenge, a dare whispered across the void, a dare we are determined to accept. The journey to Europa will be fraught with difficulties, but the rewards could be beyond our wildest dreams. As we prepare for this monumental task, we are reminded of the indomitable spirit of exploration that drives humanity forward.
Reaching for Europa demands a new era of technological innovation. This distant moon of Jupiter, with its icy surface and hidden ocean, presents both a tantalizing target and a formidable challenge for space exploration. The journey to Europa is not just a leap in distance, but a leap in our technological capabilities. The journey itself will require propulsion systems far surpassing our current capabilities. Current rocket technology, while advanced, is not sufficient for such a long and demanding mission. We need propulsion systems that can provide sustained thrust over long periods, ensuring a faster and more efficient journey. We envision spacecraft powered by fusion engines, shortening the travel time and allowing for larger payloads. Fusion technology, which mimics the processes powering our sun, could revolutionize space travel, providing a nearly limitless source of energy. This would enable us to carry more equipment, supplies, and scientific instruments, crucial for the success of the mission. Landing on Europa's icy surface presents another hurdle. The moon's surface is covered in a thick layer of ice, with unknown terrain features that could pose significant risks to landing spacecraft. Precision landing technology will be essential to ensure a safe touchdown. We must develop robust landers capable of withstanding the intense gravitational forces and the unforgiving terrain. These landers will need to be equipped with advanced navigation and hazard avoidance systems to safely navigate and land on the icy surface. Once on the surface, our ingenuity will be tested again. The harsh environment of Europa, with its extreme cold and radiation, will require innovative solutions for human and robotic explorers to operate effectively. Engineers and scientists will need to develop new technologies to protect and sustain life in this alien world. We must penetrate the icy shell, which could be miles thick, to reach the hidden ocean below. Advanced drilling technology will be necessary to bore through the ice, allowing us to access the subsurface ocean where we hope to find signs of life. Autonomous robots, capable of withstanding extreme pressure and navigating the dark depths, will be our eyes and ears in this alien environment. These robots will be designed to explore the ocean, collect samples, and send data back to the surface, providing invaluable insights into the potential habitability of Europa. Communication with Earth will be crucial, demanding advanced relay systems to transmit data across the vast gulf of space. These systems will need to be highly reliable and capable of handling large amounts of data, ensuring that the information gathered on Europa can be sent back to Earth for analysis.
Colonizing Europa will be fraught with challenges. The journey itself will be perilous, exposing astronauts to prolonged periods of cosmic radiation. Finding solutions to mitigate these health risks is paramount. Once on Europa, the extreme cold and lack of a breathable atmosphere will necessitate self-sustaining habitats. These habitats must provide life support, shielding inhabitants from radiation and the unforgiving environment. Resource management will be crucial. We must develop ways to extract water, ice, and other resources from Europa itself, minimizing the need to transport materials from Earth. The psychological impact of isolation and confinement on colonists is another concern. Creating a sense of community and purpose will be essential for the long-term success of a European colony.
Section 4. A New Home, a New Dawn, the benefits of Europa. Despite the challenges, the potential rewards of colonizing Europa are immense. Establishing a permanent human presence beyond Earth would be a landmark achievement. It would mark a new era for humanity, pushing the boundaries of our ingenuity and resilience. Europa's vast reserves of water ice could be used to sustain life, not just for colonists, but potentially for future generations. Moreover, the potential for scientific discovery is staggering. Studying Europa's ocean could unlock secrets about the formation of our solar system and the conditions necessary for life to arise. The discovery of extraterrestrial life, even in microbial form, would revolutionize our understanding of our place in the universe.
Section 5. Europa's Secrets Unveiled. A Scientific Wonderland. Europa is an unexplored frontier, ripe with scientific possibilities. This icy moon of Jupiter has long fascinated scientists and dreamers alike. Its surface, a vast expanse of ice, hides secrets that could change our understanding of the universe. Geologists will be captivated by its dynamic surface, shaped by tidal forces and perhaps even volcanic activity. The constant push and pull from Jupiter's gravity creates a landscape that is ever-changing, a geological wonderland waiting to be explored. Studying the composition of the ice and the ocean beneath could reveal clues about the history of our solar system. By drilling into the ice, scientists hope to uncover layers that have been untouched for millennia, preserving a record of the moon's past. Astrobiologists will be eager to search for signs of life. The possibility that Europa's subsurface ocean could harbor life is one of the most exciting prospects in modern science. If life exists there, it could provide insights into how life might arise elsewhere in the universe. The ocean, potentially teeming with microorganisms or even more complex life forms, could hold the key to understanding the origins of life itself. Imagine discovering alien life forms, adapted to the harsh conditions beneath the ice, thriving in an environment so different from our own. The study of Europa's magnetic field, generated by its interaction with Jupiter's powerful magnetosphere, could provide insights into the workings of planetary bodies. Understanding these magnetic interactions could help us learn more about the internal structure of Europa and other celestial bodies. Analyzing the atmosphere, however tenuous, will provide valuable data about the composition and dynamics of the moon's interior. Even the thin layer of gases surrounding Europa can tell us much about the processes occurring beneath its icy crust. By studying these gases, scientists can infer the presence of subsurface activity, such as volcanic eruptions or chemical reactions that might be occurring far below the surface. Europa is not just a moon. It is a scientific wonderland, a place where the mysteries of the cosmos are waiting to be uncovered. As we continue to explore this icy world, we may find answers to some of the most profound questions about our place in the universe.
Section 6. Searching for life. Are we alone? The question of whether we are alone in the universe has captivated humanity for centuries. Europa offers us a unique opportunity to find an answer. The presence of liquid water, a key ingredient for life as we know it, makes Europa one of the most promising candidates in our search for extraterrestrial life. Imagine the moment we discover evidence of life, even microbial life, in Europa's ocean. Such a discovery would be a paradigm shift, forcing us to reconsider our place in the cosmos. It would ignite our imaginations, fueling further exploration and scientific inquiry.
Section 7. Life under the ice building a European society. The first human inhabitants of Europa will be pioneers, facing challenges unlike any before. They will need to be resourceful, adaptable, and resilient. Life in a confined environment, far from Earth, will demand a strong sense of community and cooperation. Over time, a unique European culture will emerge, shaped by the challenges and triumphs of life on this icy moon. Future generations, born under Europa's icy shell, will have a profoundly different perspective on the universe. They will be the inheritors of our ambition, our curiosity, and our enduring hope for a future